Then question number 11. As object of mass m moving on a frictionless plane, passing point x with the velocity v, and rises up a frictionless inclined plane of 10 to a point y, that is at the height is about x as shown in the figure. If the second object of mass m over 2 passes point x with velocity v over 2, the height which the second object will rise is. Now I will consider a common situation. Mass m, velocity v. At this place, velocity is 0. It is the maximum height of the height reached by the object. Then we can use conservation of energy between point A and B. At point A, there is a kinetic energy, half mv squared, should be converted to potential energy at B, potential energy mgh. There is no kinetic energy for this point. Therefore, we can write only potential energy for point B. Then I will subject h v squared divided by 2g. Then we can get for the second object, velocity is v over 2. Then if the new height is h dash, we have to substitute v over 2 squared. It means v squared over 4. V over 2 squared. 2g. There is a difference between velocity. Mass is cancelling out. Therefore, the maximum height reached by the object is not depending on mass of the object. Now we can divide second equation and first equation. H dash divided by h equals to, we can cancel out v squared 2g. 1 over 4 divided by 1. H dash is h divided by 4. H divided by 4 is second answer. Then second answer is correct for the question number 11. Then question number 12. The object A of mass m and velocity u moving on a smooth horizontal surface along positive x direction makes a perfectly elastic collision with an ideal object B is at rest as shown in the figure. After the collision, the velocity of A and B are. There are two identical objects. When considering the collision between two identical objects, we have to remember that if the velocity of first object is u before the collision, after the collision, velocity of second object should be u, and first object should be at rest. Velocity of first object should be 0. Then velocity of first object is 0 and velocity of second object is u in positive x direction. Answer is 1 for the question number 12. You can remember it. If there are two identical masses and colliding on a frictionless surface, velocity should be exchanged. Velocity of first object should be velocity of second object after the collision, and velocity of second object 0. Therefore, first object should be at rest after the collision. Then question number 13. A wooden block of mass m is sliding down an inclined plane at constant speed from height h above the ground as shown in the figure. The total energy dissipated due to friction by the time the block reaches the bottom of the plane is. We know that there is a constant velocity, but it can't move with a constant velocity if there is a frictionless path. Therefore, friction should be equals to weight component of the object. According to Newton's first law, we know that if an object is moving with a constant velocity, there is no an external unbalanced force. Therefore, frictional force should be equals to weight component along the inclined plane. We know that it is mg sin theta. I will explain that how can we get mg sin theta. Weight is in this direction, mg downward, and this angle is theta. We can consider this right angle triangle. Then this angle is 90 minus theta. Sum of interior angles should be 180. Again, this angle also 90 minus theta. And this angle is 90, therefore this angle should be in theta. Then we can get weight component perpendicular to plane is mg cos theta. Weight component along the surface mg sin theta. Now we have to consider mg sin theta equals frictional force. And we know that work done against the friction is frictional force multiplied by distance, moving distance. Now they have given that this height is h and this angle is theta. Therefore we can write sin theta equals h divided by distance moved by the object. I will consider it as d. Then we can find d value, h divided by sin theta. Now, work done against the friction is frictional force into distance. Frictional force is mg sin theta. It is equals to weight component. Mg sin theta multiplied by x is the displacement. We can use it h divided by sin theta. We can cancel out sin theta. Then answer is mgh. Fourth one is the correct answer for question number 30. Or we can consider, we can get this method, or we can get when considering conservation of energy. Potential energy at this point should be equal to the loss of energy due to friction, because of there is no an increasement or decreasement of kinetic energy. Kinetic energy is constant because of this object is moving with a constant velocity. Therefore, potential energy at this point should be lost by work done against the friction. Then question number 14. As shown in the figure, a ball of mass 6 kilograms released from rest at point A on a smooth track ABCD, flips without rolling. The portion DE of the track is rough. If the ball climbs until a vertical height 3 meters along the rough surface, the energy loss due to friction is. Now I will consider the conservation of energy. For the first situation, the object is at a 4 meters height. For the final situation, the object is at 3 meters height. There is a potential energy decreasement. We can write potential energy decreasement is mgh, which means height difference. It should be equals to work done against the friction. We can write work done against the friction is Fa. Mass 6 kilogram, gravitational acceleration 10, height difference is 1, equals work done against the friction. We have to find distance. Work done against the friction. Then 60 joules. Answer is 4 for the question number 14. Then question number 15. A trolley is moving with a constant velocity v. 3 men A, B and C are pulling 3 strings in such a way that their tension T1, T2 and T3 respectively as shown in the figure. When the trolley moves distance L, the work done by the men are. We have to find the work done by men. But all 3 persons, A, B and C, are in the moving trolley. Therefore, there is no work done due to 3 forces given by A, B and C, because of they are in the system. Then answer should be 5 for the question number 15. Then question number 16. When a ball of mass 0.1 kilogram is thrown vertically upward with in a vacuum, it reaches a maximum height of 3 meters. When the ball is thrown upward with the same velocity in air, it reaches a maximum height of 3 meters. The average resistive force exerted on the ball by air. We can get average resistive force F into distance. F into distance is the work done against the friction. It should be equal to the difference between potential energy for these 2 situations. We can write difference of potential energy, MGH. We have to find force, frictional force. X is the distance traveled by the second situation, it means air, 2 meters. Mass 0.1, G10, H is the height difference. At the vacuum, the maximum height is 5 meters. At the air, maximum height is 2 meters. Then difference is 3. We can find its value. 10 into 3, 30 into 0.1, 3 divided by 2, 1.5 Newton. Then answer is 1 for the question number 16. Question number 17. The graph shown the variation of force F exerted on an object P when it is moving along x-axis from x equals -5 to x equals +5. The work done of the object by the forces. They have given Fx graph, force into distance graph. When considering the force into distance graph, I will consider it as this one. It is not a graph type given in the question, but we can consider it Fx graph. When considering Fx graph, we know that work done is force into distance. It means we have to get product between physical quantities in y-axis and x-axis. We have to remember that the product of y-axis and x-axis is given by the corresponding area of the graph. This area of the graph. By using same method, we can use the area of the graph, given graph, as the work done. For the given graph, there is a rectangle. We can get area of given graph. Length into breadth. We can consider length is starting from -2 and ending at +3. -2 to +3. It means length is 5 units. 5 meters. Breadth is 10. 5 into 10, 50 joules. Then answer is 4 for the question number 17. Question number 18. A particle of mass m1 moving with speed u along positive x direction, colliding elastically with another particle of mass m2 at rest. Which of the following statement made regarding the motion of particle after the collision is incorrect? We have to find the incorrect statement. It should be 1, 2, 3, 4, 5, not A, B, C, D, E. Statement A, if M1 is less than M2, then M1 and M2 move in minus x and plus x direction respectively. Now they have given that there are two particles M1 and M2. M1 moving with speed u, v, x direction colliding elastically with the particle M2 at rest. M2 is at rest. There is no velocity. Then, for the first statement, they have given if M1 is less than M2, this mass is small. If this mass is smaller than this one, M1 should be move in opposite direction after the collision. Then 1 is correct. You have to find incorrect statement. 2. If M1 is greater than M2, both M1 and M2 move in x plus x direction. Yes. If this mass is a greater value, both objects should be moving this direction after the collision. It's also correct. Third one, M1 and M2 would move together as a single mass with a speed lower than v in plus x direction. Yes, if M1 and M2 move together, the final velocity should be less than this value. They have given that the collision is fully elastic. For fully elastically collision, we can't get a motion after the collision as a single object. Therefore, statement 3 is incorrect. Then answer is 3 for the question number 18. 19. Two small spheres A and B of fully of mass m and 3m respectively are suspended from a ceiling by means of strings of equal length. Sphere A is drawn aside so that it raised to a height h as shown and then release sphere A. Collide with sphere B, which is at rest, and they stick together. The maximum height which the composite body string is. Now there are two objects. Then releasing this object at its height, we can get the motion of first object. When considering motion of first object, we can use for the mass the conservation of